Alright, so we are on dividing complex numbers. So what do I need to do to divide complex numbers? Multiply by the complex conjugate. Okay, so the complex conjugate is going to be 8 minus I. So you're basically foiling the bottom because you don't want i's left on the bottom, and then on the top you're distributing. So what does that give me on top? Over just multiply them. No, I is not -1. I squared is -1. Well, no, you're foiling, but you have plus 8i minus 8i, so that's going away. Alright, now we need to rewrite this. Okay, I squared is -1. So I need to rewrite this as 56i plus 7 over, what's the bottom? 65. Am I done? No, what's wrong with it? It's not in standard form. So to get it in standard form, I need to flip these, and I'm also going to write them as two separate pieces. Okay, it has to be written as two separate pieces. So 7 over 65 plus 56 over 65, and then the I goes behind it. Okay, so you still have your real piece and your imaginary piece. Nope, because I just said it has to be written as two separate pieces. You have to have the real part and the imaginary part for it to be in standard form. Alright, 30. -2 minus 5i over 3i. What do I need to do to get rid of that I on the bottom? Or just I? Because this is just a single term here. This was two terms. We had to get rid of the I. The only way to do that is to multiply it by this. So what does that give me on top? And the bottom? Simplify the top. And the bottom. Two and 3 are both negative, so that has to become positive. Yep. Yep. got to be written as two separate pieces. Got to have a real part and an imaginary part for it to be in standard form. The negative on top, just the 2. Just the 5. Or just that first fraction. It doesn't matter if it goes on top or bottom. Kinda, yeah. Basically, you just can't have an I in the denominator. So you got to get rid of it and move it to the top. So it's basically just whatever can you, like, can you multiply the denominator by to get rid of the I? So in this case, we just needed to multiply by I. In the first one, we had to multiply by the complex conjugate, because if not, you would still end up with I's in the bottom. Alright, I want you guys to try 32 on your paper. 7 plus 4i over 2 minus 3i. You're doing this on your own paper. Tuesday. Garrett, where's your paper? Alright. What do we get? Okay. Alright, what do we get? Two terms.
Oh,
Okay, so on top, because there was only one term here, so I can do that. If I multiplied this one just by I, on the bottom I would get 2i minus, or plus 3. So you got to get rid of the i's on the bottom. If there's two things being either added or subtracted, you need to multiply by the conjugate. Hold Hold on. Because that's not the rule of a conjugate. Seven times 3i. Yes. Yes. And then you just gotta simplify stuff, so like the I squared makes that negative 12, so 14 minus 12. Combine the I terms on the bottom, you just gotta fix the I squared to be negative 1, and then that gives you 13 on the bottom. 33. No. I don't think so. Yeah, it's a 6. Do what? If it can be, you do, but I don't think. As long if there's something you can like take out of it or like reduce it top and bottom, yeah. I'll give you like 30 more seconds. You have something written down on your paper, Garrett? Alright, what do we get? Do we see what happened? Yes. Do we see what happened? Yeah. Alright, so now we're going to graph complex numbers. It's way easier than you think. Literally, it'll be like nice, easy points on a test. Or quiz, or whatever is Tuesday. Quiz, yeah. Alright, anybody still need this page? Take it away. Okay, cool. Alright, so in complex plane, complex numbers correspond, yeah, like a quick thing, and then we're doing examples that go with it. No, this is still the same section. To a point on the complex plane. The y-axis is the imaginary axis. X-axis is the real axis. So this really is no different than graphing a regular number, other than the fact that it's way easier. It's just graphing a point. We wouldn't be graphing that. You'd be graphing something really easy. Yeah, we're getting ready to do it. Alright, so we're going to set up a graph here. Go out to like go out to like 5 on all the axes. Well, for right now. Alright, so what you need to know is that, I'm going to try to write it in yellow and hopefully it'll be visible, but that way it's not like in the way. So my x-axis is real, so this is like 1, -1, and so on. The y-axis, this is I, this is down here -I. That's like really small, but that's what's going on. So your i's are on your y, your regular numbers are on your x-axis. Just draw the plane. That's all you need to do right now. We're going to do 34. We're going to do 36. 38 is not going to fit on our graph, so then we'll also do 40. So when you graph these in the homework, you will be allowed to graph them all on one plane. But when you do that, you need to label your points with what number what number problem they go with. Okay, so I'll show you what I mean here when we do this one. Does everybody have your plane drawn? Because I want you to be able to watch what's happening. It's real. Okay. One and -1. Okay, and you need to at a minimum label 1 and I on all of your graphs. That way I can see and make sure you know what you're doing. Okay, the -1, -I don't need that. I just need 1 for you to show me that what your increments are and everything. Okay, so when we graph these, super easy. Okay, 1. I go over 1 on my, I don't know why I have another yellow marker. Hold on. You go over 1 on the x. It's got 2i, so I go up to 2i. I plot the point. That was problem 34. Yeah, that's it. That's why I said do all these on the same one. No. These ones, okay, look, if it doesn't have a real term, this one doesn't have the real term, it only has the imaginary term. It doesn't move on the x. It just, basically it's a 0 here. There's a 0 there, so I stay on the y-axis. It's down to negative 6i, so you need to add in one more. Plot the point there at negative 6i, which is literally just going down 6, and that's problem 36. So what happens with problem 40? Yep, just go right 7. And that's problem 40. Okay, super easy. So I might give you like 3 of them to plot, but you just plot them all on one coordinate. Just label them like this. Do not give me separate ones. Give them all to me on one. Okay? Yeah, I just have that it's labeled I1, negative 1 over here. Down. Negative I goes down. Positive I goes up. Negative 1 goes left. 1 goes right. Yes, all you need to write is the 1 and the I. I'm just writing this so you can see what happened. Alright, last thing we need to do is the absolute value of a complex number. It's easier than you think. Alright, so z is equal to a plus bi. The absolute value of z is a non-negative, and leave some space over here on the right to draw a picture. The non-negative real number defined as the absolute value of z is equal to the square root of a squared plus b squared. Hopefully that looks relatively familiar. This is the distance between z and the origin in the complex plane. So over here I'm going to draw just the quadrant 1. This is my imaginary axis. Down here is my real axis. I'm going to try to use some colors here so we can hopefully see. So my real value, a, from the a plus bi, is here. My imaginary term, bi, is here. So then I'm going to write this. Well, I'm going to draw the line with the big Sharpie, and then I'll write it in the little one. So then this is what we're finding here. This is the absolute value that's in blue. That's the absolute value of z is equal to the square root of a squared plus b squared. So z is equal to a plus bi. Okay, this I'm sure it kind of looks confusing at the moment, but the problems are really almost just as simple as these graphing ones. That's what it should remind you of. Alright, so problem 42. 4 plus 3i, and I need the absolute value of it. So, it's really this simple. You write the square root of 4 squared plus 3 squared, and what is that? What's 4 squared plus 3 squared? Square root of 25, which is 5, and you're done. Let's see. If there's not a real term or an imaginary term, you just put a 0 there. Okay, so it's just 0 squared. 44. This will be the last one, and then I'll give you your problems. The absolute value of 10 minus 7i. So what do I put here in the square root? And what does that give you? Square root of 149. Is there anything that can come out of that? Nope. Nothing can come out of it, so you can just leave it. If there's something that can be pulled out, then do that. But like this one, there's nothing that can be pulled out. No. You're going to submit it all together. You do it all together on the same assignment. Yes. But you still have about 20 minutes, and you should have been able to knock out most of them yesterday, I'm pretty sure. That I gave you yesterday. And I'm only adding 4, so yeah. Well, I might add 5, actually. Because I'm giving you several of the ones that you're graphing, so that's why I need to actually add those. Okay, it's going to be like 5 because the graphing one's all going on one problem. So in terms of the dividing ones, 29 and 31 are the ones that you're multiplying by the conjugate, stuff like that. Then the graphing, you're going to do, okay, all on one problem, 35, 37, 39, and 41. Okay, because those are all going on the same thing, so it's literally just one problem. And then 43 and 49 for the absolute value ones, like these down here. So, and you have the rest of class to do that. So use your time wisely.